Last chapter of pre-cal! Yay! Okay, in this chapter, we're going to be talking about conic sections. In this first section, we're going to be looking at parabolas. So this is stuff that you did back in Algebra 2, or maybe not. Depends on when you're having pre-cal. So first thing, we're going to words. You at least saw it in Algebra 1, at least, I guess, though. At least, I used at least twice. No, I just used at least twice. Yeah, it's 5 times now. Okay, anyways, so I'm going to draw a parabola real quick, and we're going to define different parts of a parabola. Okay, so everybody knows that this is a parabola. The point where it changes direction, this is called your vertex. Vertex. Yeah, it's so pretty, vertex. The line, the imaginary line that goes through the vertex and splits your parabola right in half, that is called your axis of symmetry. Axis of symmetry. Yay. Mr. Pike's so good at writing things. Okay. Now, there's other things that we are going to explore. One of these things is called the focus of the parabola. Focus. Okay, so let me pull up an image so that we can talk about what the focus actually does for our parabola. So what the focus is say we have a satellite dish here. And you can see that it's like a really wide parabola, right? So all that the focus does, this is actually the focus of that parabola right there. It will take any ray, so say I'm shooting a ray down, it hits the parabola at that point, it hits the ray, or the disk, and it is going to bounce and reflect off of it straight through the focus. So all this little thing does here, notice it's on every single satellite. Whoa! Man, I never noticed that before. That one's even kind of cool. It's like a Death Star one. Right, but every satellite is going to have that thing, and it is actually getting the radio waves that are bouncing off of the dish, and it is going to that little point right there called the focus. So that is what helps us to find where our waves are going to. Same thing, if you shot a ray of light and hit the disk, it would bounce back through the focus. So that is what the focus is called. That's kind of why it's called the focus, because all of your things are focusing on that point. On the opposite side of the focus, we have something called the directrix. It is actually a line, directrix, the same distance away from the vertex of the focus. And this distance that it is away, this distance is p. Same thing, this distance is also p. So when I write my equation in standard form, this will all make sense to you. Vertex, we will call it hk. Yay, it is some points. Oh no, school's out! Okay, so here I kind of have two different standard forms of the parabola. Notice you can see 4p in your equation. You can see the vertex hk. The vertex is the same in both of these. Vertex hk. And then I can find p by using this 4p on the outside. Okay, with these shapes, notice you have x squared in this one. So all that means is it is going to go up or it is going to go down. It will go down when p is, or sorry, it will go up when p is positive. It will go down when p is negative. Okay, we'll explore these. Likewise, over here, notice you have your y squared, so it is going to open up to the right or open up to the left. So again, if p is positive, it is going to open up in the positive direction. If p is negative, it is going to open up in the negative direction. Okay, the directrix and the focus, again, they're the distance p from the vertex, and they will always be on the line of the axis of symmetry. So let's actually find a few of these things, and let's explore some. Okay, looking at our first example, it says identify the vertex, axis of symmetry, focus, and directrix, then graph. So with this, for my vertex, it's pretty easy to pull out of this as long as it's in standard form. So I have with the x is a 2, so I'll pull out -2. With the y is a -1, so I'll pull out 1. Hey, oh, there's my vertex. And notice, since my squared is with my x, and it is negative on the other side, p is negative, what that means is it will open down something like that. So if I know that the vertex is -2, 1, then the focus is going to be below, the directrix is going to be above, the axis of symmetry should be x equals whatever the x value is, so -2. So now if I graph this, I have -2, 1. There's my vertex. It is going to open down. And to find my focus and directrix, I need to know what p is. So if I know that 4p is equal to negative 16, then p is equal to negative 4. So that tells me I'm going to go 1, 2, 3, 4 units, and 1, 2, 3, 4 units. Since it is opening down, there's my focus. So my focus should be negative 2, negative 3. And my directrix is the line y equals 5. Cool, because notice that is 4 units away from the vertex in either direction. So there we go. There we go. Yay, happy day. So pretty. Okay, looking at another example. So in this one, again, starting from the beginning, vertex looks like with my x, I have a negative 1, so I'll choose 1, negative 3 for my vertex. My axis of symmetry, well, since it is x squared, it is going to open up or down. Since it is positive p, it is going to open up. So I have negative 1 or 1, negative 3, so to do something like that. So my axis of symmetry then should be x equals 1. Now for the p, 4p equals 2, which means p is 1/2. My focus will be above, my directrix will be below. So I have, for the focus, it moves up 1/2, so 1, negative 2.5, and the directrix will move down 1/2, so y equals negative 3.5. Cool. And then from there you can graph. That's kind of blurry. Let's focus. And it's a little bit better. Sorry. So you have 1, negative 1, 2, 3. There's your vertex. There's your focus. Your directrix is right below. And there would be your parabola, something like that. I'm not too concerned about the other points. Yay. Okay, doing another one. Same sort of deal. So our vertex, with the x, we have a plus 1. So vertex, I have negative 1, negative 3. Notice, since your squared is with the y this time, that means it is going to open left and right. And since my p is positive, that means it is going to open to the right like that. So my focus will be on the right-hand side. There's my directrix, something like that. So for my axis of symmetry, that means I will have y this time equals the y value, so negative 3. And my p, I have 4p equals 10, so p is 2.5. No, I lied. No, I didn't. Okay, so then since it is going to the right and left, I will have plus 2.5 from the vertex for the focus. So the focus should be, let's see, plus 2.5 from the y will just be negative 1. No, I'm lying. It's not on the y, it's on the x. I'm sorry, 1.5, negative 3, because the y value doesn't change, but the x does because it goes left and right. Yay. And the directrix will go to the left 2.5. So we have left 2.5 would be x equals negative 3.5. So then for your graph, you have vertex is negative 1, negative 3, somewhere down there. Your focus is 2.5 units this way, so 1.53. Graph is beautiful. Oh yeah. Okay, with this one, notice it's not in standard form. So I need my numbers together, so it looks like since this isn't something something squared, y minus something, y minus plus minus something, right, it's just y squared plus 33. I'm going to move this 33 over, so if I subtract it to the other side, then I would have y squared equals negative 8x minus 56. And notice with this, on this hand side, it doesn't quite look like standard form. I can't tell what my p is yet. But if I rewrite this and factor out negative 8, then I have x plus 7. And hey, oh, notice I have y squared. Well, it doesn't matter if there's y plus or minus something. If there's plus or minus nothing, then it would be 0. So your vertex for this one would be negative 7, 0. Your y squared, and then your p is negative, so we will have something that opens to the left. Okay, go ahead and take a second and give everything else a shot. I'm going to write it out real quick for you. Okay, so now I can figure out that the p is negative 2. I know my vertex is negative 7, 0. Since it is going left and right, that means the axis of symmetry is going through the center, so it's line y equals 0. The focus, since my p is 2 away from the vertex, and the directrix is also 2 away from the vertex in the opposite direction, so there would be all of your stuff. Cool. Okay. Oh, this one's just a little bit different. Let's mute that, get that out of there. Because we have a y mixed in with a couple of x's, so I know I want to have x minus plus or minus something squared. Well, the only way to do that is if we remember back from Algebra 2, and we did something called completing the square. Well, first I'm going to move over this 12y to kind of make it a little bit easier on myself. So I have 12y minus 33 equals x squared minus 6x, and I need to turn that into a square term. Well, in completing the square, I'm going to add some number to both sides, plus some number, x squared minus 6x plus some number, right? This number that goes here is always going to be this number divided by 2 and squared. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. What I add to one side, I must add to the other as well, so I'll add 9 to that side. So I'll have 12y minus 24 equals x minus 3 squared is how that will factor. Cool, so now I have an x minus 3 squared term. So then here, just like I did in the last one, I'm going to factor out a 12, so I have 12 times y minus 2 equals x minus 3 squared, which will help me determine that the vertex from this point is 3, 2. And I can find everything else that I need to from there. You have 4p is 12. You can find your p. Everything else should be a piece of cake. Okay, I'm going to do another complete the square one with you guys. Again, in this one, the x's and y's are on different sides, so since I have y squared, I'm going to move over the 6y. I'm also going to move over the 21. So I'll subtract 21. Yay, yay. And add add 6y. So I have y squared plus 6y equals negative 20x minus 89. So again, completing the square, you will add some number. So y squared plus 6y plus some number equals negative 20x minus 89 plus some number. My middle term again is 6. 6 divided by 2 is 3. 3 squared is 9. And 9. It will not always be 9, so do not just assume that it is 9. So y plus 3 squared equals negative 20x minus 80. And then you can factor that, so you have y plus 3 squared equals negative 20 times x plus 4. And again, you can get your vertex, and this one would be negative 4, negative 3. Your axis of symmetry, you can find it, and all of the other things you can find. Okay, looking at a different type of problem next. All right, with this one, it says write the equation of a parabola with given focus f and vertex v. It tells us our focus, tells us our vertex. So if I know that the vertex is negative 9, negative 4, it's over here somewhere, and the focus is negative 9, negative 7, that's my vertex, negative 9, negative 7, so that means that's going to be even lower. So there's our focus, which that would mean that my parabola is opening down. So I know that in order to write standard form, I will have the x squared, since it is 9 there, it will be plus 9, equals, I don't know, 4p, and y plus 4. Cool, so now that I know all of this, if I find this distance, which is 3, then I know that p is 3, and in this case it's actually negative 3 because it's opening down, which would tell me that 4p is negative 12, so that is a negative 12 right there. And there would be your equation. Oh, yeah! Okay, same sort of deal here. I'm going to graph where my focus and where my vertex is. So my focus is negative 3, negative 2. So there's my focus. Vertex is 1, negative 2, so it's on the same line in the y direction. So there's my vertex, which means my parabola opens that direction. So it looks like in this one I will have the y squared, so I can say y something squared equals 4p something x something. Since I know my vertex, I can say y plus 2, x minus 1, and then I know the distance here from negative 3 to 1 is 4 units, and it's actually again going to be negative since it is opening to the left in the negative direction, which would mean 4p is negative 16. So I have negative 16. There's my equation, Happy day. Good to go. All right, last example. Determine the orientation of the parabola. So all it's talking about there is whether it opens up, if it opens down, opens to the left, opens to the right. So in this one, if the directrix is y equals 3, well, if I draw my picture, that means the directrix is here, which tells me that my parabola could open up, it could open down. I'm not really sure, but it's one of those two things. It also tells me p is -1. So if p is negative, then I know it has to open down, so that's all I'm going to say, opens down. Yay, we did it. Okay, in the next one, your vertex is -3, 2. So if I go -3, 2, the focus is -5, 2. That's my vertex. So the focus is further, same on there. So there's my focus, which means it would have to open up something like this. So all I have to say is opens left. Yay, happy day. Hopefully this video was helpful for you guys. If not, make sure you come ask me questions. I'll be more than happy to answer them for you. In the meantime, there's a monkey. Yay! Bye!